Hey y'all, look what I got. Safe Dose Ranges, part 3. I know, I'm pumped too. Okay, here we go. It says the recommended dosage of gentamicin IV piggyback for a child is 6 milligrams per kilogram per day in 2 equal doses. The child's weight is 44 pounds. The drop factor is 60, and the medicine is available at 60 milligrams and 100 milliliters to infuse over 90 minutes. Okay, take a swallow of your beverage. The first thing you got to do, you can't fart till you convert that weight. So we're going to take 44 pounds and divide it by 2.2. That's the first step you're going to do. All right, so here we go. 4 divided by 2.2 equals, look, smooth 20. Isn't that wonderful? 20 kilograms what the child weighs. And so they're saying that it says calculate the dose for this child. And it says 6 milligrams per kilogram. And look, we got 20 of them. So we got to multiply 20 times 6 milligrams. And if you don't trust your brain, I understand. We're going to do times 6 equals 120 milligrams. And this is what? This is per day, you see? And look, I'm going to put that so I can remember where I'm at in the problem. And it's got to be given in 2 equal doses. So we're going to divide 120 by 2, and it'll give us the milligrams per dose. And look, 120 divided by 2 is 60. So it'll be 60 milligrams is going to be the dose. Look, we got the child's weight right. And then look, we saved him again, 60 milligrams a dose. And then Ethel wants to calculate the rate in milliliters per hour and drops per minute. So we're going to give her what she wants. Or Engelbert, if you got a male. Anyway, we're going to just focus on the milliliters per hour. And you remember the formula for milliliters per hour is the total volume divided by your time in hours. So our total volume, it says right here, the medication is supplied 60 milligrams and 100 milliliters. To do a milliliter per hour, we're not worried about the milligrams. We want the liquid. Just the liquid. So 100 milliliters is the total volume. And it's got to go in over 90 minutes. There's 2 ways you could do it. You could do 1.5 hours. And if we did that, this fraction says 100 divided by 1.5. So 100 divided by 1.5 equals, look, we're not scared of that. We know the man that trumps it. But it'd still go at 67 milliliters an hour. If you were going to do the milliliter per hour problem, and you were going to put 90 minutes, if you've watched some of my other videos, if it's milliliter per hour and you're going to write the word minute, we're going to throw a 60 up here on the top to tell the problem that we're dealing with a 60-minute hour, not a 90-minute hour. And then we would do all the math on the top and divide it by the number on the bottom. And I'm going to show you, we'll come out the same thing. I hope this didn't just throw somebody. Divided by 90 equals, yeah, see, all them numbers that don't intimidate us. It would still be 67 milliliters an hour. Okay. And she wants you to, look, let me show you we saved him. Come on now, Dookie fart. Here we go. See, boom, saved him. Okay, and then calculate the drops per minute. So, remember drops per minute? I'm going to remind you. It is the total volume times the drop factor divided by the time in minutes. It's got to be in minutes. That's drops per minute. So let's find this. Total volume is 100 milliliters. The drop factor is 60. I know it's going to end up looking the same as the other one we just did. And over 90 minutes. And so we'll do all the math on the top divided by the number on the bottom. 100 times 60 equals divided by 90 equals, We don't care because it's 67 drops per minute. Okay, look, boom. We saved another one. I hope it helped. I hope it made it so clear that you just go in there and say, let me show you how to do this right here. Well, y'all like this video and share it and comment. I'm picking up what you're putting down. That'd be cool. All right. Thank you for watching. I got some heparin coming up. Y'all have a good day.